Hi there, welcome to another revision video for A2 Geography on part 3 of the Tectonics section covering seismicity and case studies. So I will be looking at the causes and characteristics of earthquakes, looking at the focus, epicenter and seismic waves, earthquake measurement and the 3 Ps, and tsunamis, causes and characteristics, and finally earthquake case studies. What is an earthquake? An earthquake is a motion of the ground surface ranging from a faint tremor to a wild motion capable of shaking buildings apart. A type of energy in the form of wave motion transmitted through the Earth's surface. Produced by sudden slip movements along faults, volcanic activity or man-made influence, such as digging, building and mining. An example is in fracking, which has been known to cause tremors. Previously measured using Richter scale, which is logarithmic, and Mercalli scales, but now the MS is more commonly used, which I'll talk about later. Earthquakes are particularly common along ocean trenches at subduction zones, in regions where continental plates are colliding, for example Nepal, along ocean ridges, for example Iceland, and transform faults, for example the San Andreas fault, and they're less common within plates, so well away from plate margins, where fixed faults slip, and also at hotspots. Terminology and what are seismic waves? Focus. This is where the fault happens. The epicenter is above the focus on the surface. Wave front is just the front of the shock waves. Seismic waves are waves of energy caused by sudden breaking of rock within the earth or an explosion. Can be recorded by seismographs. Primary effects of earthquakes: ground shaking. Secondary effects: soil liquefaction. This was seen in Japan 2011. Soil loses mechanical structure and it behaves like a liquid. Landslides, slope failure due to the ground shaking. Collapse of infrastructure, so buildings, transport systems and power lines, for example. Destruction of utilities such as water, gas, electricity, along with internet connections. Fires, ruptured gas mains, fallen power lines. Flooding from groundwater and mains water. Disease and food shortages. And also you can have a knock-on effect, which is a tsunami, for example in Japan 2011. Main types of seismic waves. We have body waves, and these can travel through the Earth's inner layers. Surface waves, which only move along the surface of the planet. Earthquakes radiate seismic energy as both types of these waves. So body waves, we have primary or push waves, and these can travel through solid and liquids. And secondary, which is also known as shear waves, only travel through the surface. Surface waves, we have longitudinal waves, which up and down movement like a worm, or transverse waves, which is side to side movement. And finally we have Rayleigh waves, which are longitudinal and transverse waves combined to produce waves in a circular motion. Earthquake measurement. So the 12-point Mercalli scale. This is the measure of the intensity and impact of an earthquake on people and environment. 12 being a powerful earthquake with total destruction, so very little left, 6 being some damage to objects, cracking of walls, and 1 being only detected by seismographs. An advantage for this, it's useful for people to measure the actual damage rather than just the magnitude. However, the disadvantage is that it's not scientifically accurate. It's based on subjective observation and an estimate as to where an event lies on the scale. This is not good for making a comparison against other quakes. Richter scale. This is a logarithmic scale measuring the magnitude or energy released of an earthquake based on seismograph readings, which are measures of the passage of shock waves. Each point from 1 to 10 represents a tenfold increase in the amount of energy involved. 1 being only detected by seismographs to a very rare 10 being complete destruction, causing massive loss to life and almost irreversible effects to landscape. An advantage is this is actually scientifically accurate measurement and is useful for comparison. Finally, we have the moment magnitude scale, or MMS. This has more recently been used as it takes both previous scales into account. It gives more accurate and detailed representation of an earthquake and does allow for good comparisons. It measures mostly magnitude, but also takes into account the intensity of the earthquake from the Mercalli scale. So it combines the Richter and Mercalli scales together, in a sense. An example where they've used it is the Nepal earthquake in 2015. In terms of seismometers, seismometers are placed in the ground and detect vibrations in the ground, which are then displayed on seismographs. USGS, or US Geological Survey, use these, particularly in monitoring Yellowstone supervolcano activity. Okay, the 3 P's: prediction, prevention, and protection. Prediction. It's very difficult to predict earthquakes. Regions at risk can be identified, but attempts to predict are quite unreliable. Prediction is based on monitoring groundwater levels, releases of gases, and unusual animal behaviour. Fault lines can be monitored, and a hazard zone map can be produced based on studies of ground stability to be used by planning authorities. Prevention. Thought by most to be impossible to prevent an earthquake, although studies have been conducted into somehow lubricating the movement of plates sliding past each other so they do not stick and build up pressure. Protection. Hazards. Resistant structures, so buildings designed to be aseismic, e.g. having the ability to move with the seismic waves rather than against them, and this was happened in Japan. It's used in Japan. Education, so authorities issue instructions on how to prepare. Again, this was used in Japan in 2011. They displayed messages on TV about the earthquake happening. Emergency planning. So again, computer programs used in Japan, and these alert people via media, sending messages out, sending the warning out of an earthquake or a tsunami. Insurance. So people urge to take insurance to cover their losses, as it can be very expensive. And finally, aid. So emergency aid sent after the event, medical tents, food, or for longer term, rebuilding. Tsunamis. Causes of tsunamis. So definition of tsunami is any wave created by a geological stimulus, for example an earthquake. A tsunami or harbour wave describes more than one wave. It's mainly caused by tectonic plates moving at subduction zones. Underwater earthquakes, as a result of the seafloor becoming deformed, trigger a vertically displaced volume of water with waves moving outwards. Characteristics of tsunami. 90% of tsunamis occur in the Pacific Basin. Tsunami waves travel very fast, up to 800 kilometers an hour, but their destructive power comes from their towering heights which they attain as they approach the coast. The steepness of the coastland determines the size of the wave. Types of tsunami. So we have a trough first tsunami. This was seen in Miyako in Japan 2011, where water will receive, giving warning, and it will keep going back at a faster rate, but then a wall of water will then approach. And then the second type is crest first, and this was seen in Ofunatu in Japan, where a wave hits with no warning, and in this case 95% of buildings were destroyed there, and many people died. Okay, these are my earthquake case studies. So Port-au-Prince in Haiti in 2010. The Caribbean destructive plate slipped at a conservative margin. It's 7 on the Richter scale, happened at 16:52 p.m. local time. Impacts include around 200,000 people were killed and thousands more injured. Thousands of collapsed buildings, and many people were trapped inside these. There was violence and there was looting. Aid was sent from the west. food, shelter and water, for example, these sort of things. There was forced mass migration, with 1.2 million people becoming homeless. Responses include people had to help themselves. So, for example, only one ambulance service was run originally by a volunteer. No international aid due to security concerns initially. Armed forces and military arrived as they thought that there would just be violence, and there wasn't, that people were crying out for aid, help with food and shelter, not widespread violence. So that didn't really help much. Global relief efforts, so people relocated to a site with tents and provided many NGOs, non-government officers, to help. Shortage of drinking water, so government stopped some aid from arriving at the airport. L'Aquila, Italy, 2009. Information about it: city with around 70,000 people. Area was prone to earthquakes because of a major fault lines close to the destructive plate margin between the Eurasian and African plates. Earthquake occurred at 3:30 a.m. local time on 6th of April 2009, measuring 6.3 on the Richter scale, caused by movement along the north-south fault line. Economic impacts. Estimated cost was $15 billion in total, and fires in some collapsed buildings caused more damage. Thousands of buildings, both historic and modern, were damaged or destroyed, including part of the city hospital. Social impacts. These include around 300 deaths, mostly caused by a collapsed building, and 1,500 people roundabouts were injured, and 70,000 people made homeless. Aftershocks hampered rescue efforts and caused more damage, and thousands of people, many young, had to migrate from the area to find jobs after buildings were destroyed. Environmental impacts. These include an area of about 1,000 kilometres squared was affected by surface ruptures, rockfalls and landslides. For example, a broken water pipe near the town of Paganitha caused a landslide. And also, wildlife habitats were affected as well. Responses. Camps were set up for homeless people with water, food and medical care. Emergency services along with the army were sent in to rescue survivors. 12,000 rescue and support workers were brought in. Money was provided by the government to pay rent. Mortgage payments, gas and electricity bills were all suspended as well. This was all to help the victims. The Prime Minister promised to build a new town to replace L'Aquila as the capital of the area. By the end of 2009, 4,500 new buildings had been put up to house 12,000 people who had been made homeless. Management. Prediction. So seismologists were monitoring the area, and some felt the hazard could have been managed better. There was a lot going on in the news about scientists saying there wouldn't be an earthquake, and obviously because this happened, a lot of the blame is put onto them, because they said, but it's difficult to predict earthquakes, and that's the thing about this. Planning. Italy has a civil protection department that trains volunteers to help with rescue operations, and building techniques, strict regulations so that new buildings were built to withstand earthquakes. Okay, market raisin in Lincolnshire, 2008. It's a small earthquake. So the strongest for 25 years. It was 5.2 on the Richter scale. It struck at 56 minutes past midnight, so it was dark and it was cold. 18.6 kilometres was the depth. There were no deaths, but buildings were destroyed. Some roofs were damaged, mainly falling masonry. Panic. So there were calls made to emergency services, and aftershocks were felt for hundreds of kilometres away. Cost was around $30 million, mainly to insurance companies. Okay, Nepal. This is a recent earthquake case study, April 2015. 7.8 magnitude quake. That's the MMS scale. Struck Nepal on Saturday, April 25th, 2015. flattening large parts of the capital, Kathmandu, and causing devastation across the impoverished Himalayan nation. Here's some key facts. So Nepal's worst natural disaster in 80 years, with over 8,700 people dead and more than 505,000 homes destroyed. The area was hit with a second 7.3 magnitude aftershock quake just 17 days later, hampering rescue efforts. 80 million people, so that's 1 in 4 people living there, living on less than $1.25 a day, which is classed as in absolute poverty. The highest loss of life was in the capital Kathmandu due to its dense population, so there's links to population and urbanisation there, and the number of buildings, many of which collapsed during the quake and aftershocks. 1.4 million are in need of food and assistance, and tens of thousands were without shelter. Many aid agencies were supplying aid to those affected, but this is hampered by Nepal only having one airport with a single runway, and heavy rain and cold nighttime temperatures put those without shelter at a greater risk. 40% of Nepal was affected, as well as deaths reported in India and Tibet. 2.8 million Nepalese were displaced, and estimates that 8 million people were affected by this earthquake. Okay, my tsunami case studies. Japan tsunami, March 2011. Cause: earthquake was 100 kilometers off coast, beneath 6 kilometers of water, so primary waves travelled at 6 kilometers a second or 800 kilometers an hour. Very fast. Warning system was in place, and it did alert people, shut down the nuclear reactors. It was a magnitude 9 earthquake that hit first. A specific place to look at is Miyako. It had tsunami defences, a 10-meter high wall. It spent millions and practice drills. Warnings did save some lives. This 10-meter high wall wasn't high enough though. Impacts. Earthquake so massive it lowered the coastline by 1 meter. There were 420 aftershocks and 20,000 people died because of this. Over 100,000 buildings were destroyed. Fukushima nuclear power plant overheated. Radioactive substances escaped, leaving 35,000 homes uninhabitable. Huge economic losses. For example, Panasonic lost $9 billion the following year because of this. No warning systems, and there's barely any preparation in this Indian Ocean tsunami compared with the Japan tsunami. This happened December 2004. Info and courses. So, Indo-Australian plate subducting under the Pacific plate. Earthquake 25 kilometers deep, so shallow, which means there's more energy. It was enough energy to trigger a tsunami, which is magnitude 9 on the Richter scale was the earthquake. Something called tsunami initiation, and this is where you get displacement of tons of water after the earthquake. Energy was equal to 23,000 Hiroshima atom bombs. Seabed rose by 15 to 20 meters. Some areas there's a wall of water which was 25 meters in height. Compare that to the 10-meter high wall they built in Miyako, 25 meters high. Epicenter was just off the Sumatra coast. Speed of the wave was over 500 miles an hour. Drawn water before it hit, so people went out to the coast to see as the water retreated, and that ultimately cost some lives. Estimated total cost of the whole tsunami was $15 billion. Here's some impacts. Affected Sri Lanka, Thailand, Indonesia and Sumatra, and these are all quite low on the Human Development Index. It's quite poor. Over 250,000 people were killed. Three quarters of the victims were in Sumatra. Popular tourist destinations, many people on holiday were killed, such as in Thailand. 1,500 villages were destroyed, millions are homeless, and there was damage to tourist infrastructure, so hotels, shops and bars, etc. One particular case, a train was swept off tracks in Sri Lanka, leading to over 1,000 deaths. Damage to local economies, fishing, agriculture, hospitals. In Sri Lanka, 60% of fishing industry was destroyed. Estimated disaster costs of less than $5 billion by the insurance industry alone. Okay, responses. Medical and monetary aid was given, around $1 billion given worldwide. A warning system was set up in the Indian Ocean. They provided sanitation to help contain spread of disease. Rapid burial of bodies due to this spread of disease. Food aid to 1.3 million people affected. And that's it. Alright, so thank you for watching my A-level revision videos. And do check out my other revision videos if you haven't already. Thank you.